Greetings, everyone. My name is Dave Bergman. I am Vice President of Standards and Technology for IPC, and it's an honor to be able to talk to you today about IPC standardization activity, our efforts to help the industry build electronics better through our efforts on Factory of the Future and specifically on IPC CFX. So I will start sharing a presentation now. So we have been engaged in an investment in Factory of the Future for 2 years now. We have been focusing in many areas to help the industry build electronic better, as well as they prepare their company to be a factory of the future. And we'll talk specifically on IPC CFX and how that plays an important role in this. So IPC is a standards development organization and has been for many years. We are member driven, many participants in our standardization activity. We currently have over 3,000 member companies that participate in the program globally, and we've been involved in standardization since about 1959. And then in China, our activities started in late 1997, and we have standardization activities taking place as well in Europe and China. Our headquarters is, we were founded in North America in 1957. We have European offices starting in 2004. We've been in China with multiple offices since 2002 and footprint in both India as well as Southeast Asia and Bangkok. We're supported by many member companies and work in many areas of many industry segments. So we have the original equipment manufacturers that are supporting our standard activities in the aerospace industry, in automotive, in consumer electronics. We have electronic manufacturing companies such as Benchmark, Flex, Celestica, and Foxconn, as well as then the PCB manufacturers and their supply chain, the material suppliers, equipment suppliers, etc. We talk to our customers about the use of IPC standards. We use a tool called TechValidate to get their feedback, and we have found many positive responses. 92% support the statement that they use IPC standards because their customers feel it helps them deliver better quality. 87% of the quality departments are using the standards. The top 3 benefits are customer satisfaction, production efficiency, and workforce performance. We have a large portfolio of standards, actually hundreds. This is a small standards tree, and the most popular standards are noted in color in the center, starting at the design series of data transfer from the customer to the manufacturer, to the design of the board itself, to the materials that go into the board, the manufacturing of the board, the manufacturing of the assembly, wire harnesses, and then the final enclosures. So there are many support standards that work to support those individual ones, where it's surface finishes or additional design standards or assembly materials, the soldering, solderability, etc. And so we have hundreds of standards that help companies build product in the electronics manufacturing chain. We have had a list of many companies that have been using standards for a long period of time. 50% have been using them more than 20 years to help them build electronics better. So we started investing in the Factory of the Future effort about a couple years ago. The goal was to put a more focused effort to help industry achieve the vision of Industry 4.0, having companies collaborate with each other, develop modernization plans, and implement automation activities to help them be more efficient. This led us to standardization efforts in many new areas. These standards come are started from different regions of the world. Digital Twins 2551 started in North America. The Hermes Standard 9852 was European led. The 2552 on model-based definitions. This is currently being developed by IPC members in China, and a variety of other ones that we're looking at for the factory exchange tracing that we'll talk about more, CFX, traceability, things about component level authentication for counterfeit, protection against counterfeit, cybersecurity, etc. Many things related to moving of design and information in the manufacturing process. So there are, of course, you've heard of Industry 4.0, and many of these standards fit the overall platform to help companies implement more data-driven factories. But there's also good old-fashioned engineering to make sure your factory is working well, and so we see that that will continue. We expect that companies will move into factory automation slowly. They'll be because it is expensive to put in new equipment, so expect that there will be ranges of implementations by different companies in 2 to 5 and 10-year type of implementation plans. We see a growing level as more data can be passed through the supply chain, starting from an individual company to multiple companies working together in a single supply chain. So the OEM customer working with their PCB supplier and their EMS supplier to reduce or to achieve faster cycle time, faster time to market. Moving to where the entire manufacturing industry can work together to create larger volumes, create a global supply chain. Not too many companies currently thinking this far yet, but we see this as an inevitable future as companies work to build electronics globally. So we started building a new solution to focus on Factory of the Future. Certainly we have 20 years of what we would consider to be conventional technology, the soldering, the creation of the assemblies, but we wanted to focus more on data-driven or data-based activities to help with automation. So we've pulled together a number of industry work groups and associations to collaborate on gathering information on Factory of the Future and presenting that at different conferences, put more focus on our trade show, technical conference on F2. We've pulled together a Chief Technologist Council with subject matter experts from some of the largest OEMs in the world. We'll talk more about CFX and the digital standards that we're trying to use to help industry with F2. Some of the ones that we've started already to try and create ROI-driven solutions. We recognize that the need for management of data is very high. This led us to focus early on in the CFX area, but spending time in digital twin and digital product model exchange. There are many other of these bullet points where there are committee and standards discussions taking place within IPC committees. So we have the digital twin, we have cybersecurity currently underway. So this list of the technology stack and the data required will be an effort that continues within the organization. So I'd like to switch now and focus on the 2591. This standard is at the heart of IPC's F2 efforts. It's not the first standard. We have had multiple generations of data communication standards within the IPC. This does have some unique decision points, which we feel help CFX be positioned to help industry more than any other standard that we have developed. Certainly, OEM customers and manufacturers are expecting to use data to help them be more efficient, being able to control their manufacturing processes and reduce their overall costs. When we were discussing the standard CFX, the goal initially, key goals were plug and play. We wanted to be able to buy a machine from multiple different vendors, to recognize that it would speak a common language on delivery, and wanted to be able to have data that could be transmitted both ways, from a software system to the machine, from the machine to the software system, from machine to machine. And have this available that when you ordered a piece of equipment with a standardized language, you got what you expected and it worked out of the box, true plug and play. And that was the goal of the CFX standard. Companies spend a lot of time controlling their process by use of upper and lower control limits, monitoring what's going on in their factory. This is done at many levels within companies. The goal is to be able to extend beyond one piece of equipment to multiple pieces of equipment, and essentially look at the entire line, end up with various dashboards that can give someone a quick view of the health of the manufacturing line, and then use machine learning to attempt to increase efficiency and lower cost. This was a goal of CFX, to be able to enable these type of activities. The goal was simple, is to have a standard language where all of these machines, machine 1, 2, 3, 4, 5, to machine N, could communicate in a known language with a known set of messages, and then take those to various software handling systems, manufacturing execution systems. But also down the line, while it may be not initially out of the box, have the ability from a machine to machine feedback loop. So theoretically, a inspection system could be driving and communicating correction information to a manufacturing piece of equipment. So this is the goal, and CFX and the choices we made allowed multiple direction paths of collection of data, so that it could be consumed in various locations. So many of the standards that are involved in data transfer focus on the pipe itself, and they limit. So you have a standardized protocol for transmitting data. But if you look then at what information is transmitted by that protocol, every company has their ability to put whatever they want in there. And so you don't have clean data. You have a clean pipe, but not clean data. So when you look at the end, the company or your customer doesn't know what to expect. You've managed to have a standard protocol, but you're not transmitting standardized messages. And so the IPC committees wanted to focus on the standardizing the messages. We spent 2 years trying to address a very important aspect, was what protocol to use. We wanted to be able to have secure data. Everyone is concerned about potential hacking and such. And so using the protocol used by the banking industry, AMQP, it was the selected source. This also allows for fast transfer of information, allows for point-to-point information without the need to go through a broker. And so this was really important, an important decision in the use of CFX. We had a very light encoding. We're very well known using JSON. And then the standardized messages was a very key decision point. The goal was to create a standard set of messages that could be used in various parts of the manufacturing process. And so these messages can be produced in one location and consumed in another. And so in going down all of the messages that get created, each one can have a different area where they are used. These can be consumed by different pieces of equipment and or manufacturing execution systems, but the messages say the same. And so we can look at the CFX standard and say there's many materials related messages, and someone can go through and say, okay, yes, I understand what this message is and where I might want to consume that in my process. We spent 2 years deciding talking about the AMQ protocol, very important. We took the time to pick that individual format. And then we started doing demonstrations, and these demonstrations were done all over the world, US and Europe, in China, and the goal was to be able to show that different companies could be communicating in CFX from around the world, or through the cloud, etc., and being able to transmit and receive these messages. And so we've been demonstrating this successfully since essentially Productronica 2017 was our first attempt. We have the opportunity with the IPC committee to revise the document. We're trying to release versions on a 6-month basis as new messages get added. So the standard will evolve as the industry finds new ways to use the information that gets captured. The nice part about it is that these messages are provided in open source websites on GitHub, and companies can see those, be aware of what's involved, and determine how they might be used in their piece of equipment. So we have a standard committee, Connected Factory Exchange. We have local committees both in North America, Europe, as well as in China, to be able to discuss this in various local languages as well as local time zones. We've had hundreds of companies that participate in this, and we've gone through multiple versions. One of the key decisions took place in version 1.3 in March of this year. This was creating a standardized message set for various endpoints or pieces of equipment. So there is a standard set of required messages for a pick and place machine. That will be different than the standard mandatory messages that an AOI machine sees. And so what we wanted a company to be able to know, if I'm a customer, when I buy a piece of equipment and I'm expecting it to meet version 1.3 of CFX, I'm going to know what messages that machine will be able to produce or consume. And so we have continued to grow this, and we're expecting that we'll have version 1.4 out by the end of the year. We have many companies that are supporting this standard and have noted as being a supporter since the early development days of this. We break these into a number of categories, whether it's the equipment or software suppliers, because certainly both sides of that manufacturing effort requires a CFX interface. And there are companies that are supporting this from the manufacturing side. They're looking to help drive this to make their manufacturing operation more efficient. Another key aspect of support for this standard is the creation of a qualification program to make sure that an equipment supplier or a software supplier has a well-implemented manufacturing or well-implemented CFX implementation. We created a validation and qualification site. What this did was enabled us to have companies connect to a cloud-based tool, evaluate their CFX implementation, have this check against the mandatory list of messages required for that input, and if they judged that they were able to pass qualification, they could run a qualification routine and receive a qualification statement when it's done. And so we had these three companies in China that did this earlier this year. These three companies were the first three in China to receive the QPL listing for their pieces of equipment for CFX. We have tried to build an infrastructure for support for CFX. We have the written standard itself. The messages are on GitHub. We have online training courses for CFX for those people that want to get to up to speed quickly. We have the self-validation tool, and if support is needed, we have a consulting service program if somebody needs detailed support. And then in the end, we inform the rest of the industry as to successful implementations by listings on our qualified products list. These companies have gone through and qualified their equipment and are listed on the QPL. The ones at the bottom are ones that are currently in process, more to come, and we will continue to release information as the companies are successfully qualified. This is the link of where the certification comes from. This is fairly small, but there's 27 and growing companies that are currently on the QPL. They can be searched by company name and or equipment type, and we will continue to maintain that. We feel that this is the best way to have companies know what they're going to get when they're buying a piece of equipment that they know is qualified and is on the QPL. So what's happening as far as implementation? This one's my staff team in China asked me to talk some about this. We have been talking to many companies. We have not had companies ready to help us with a white paper to show publicly what they're currently working on, but we have many companies that we've been talking about that we know are actively working on CFX implementation. There's an EMS company in California. We expect that they will be talking publicly at our Apex trade show in January 2022 about their implementation efforts. We have aerospace OEMs in the US we know are pushing their equipment companies to have CFX interfaces. We know that 4 of the top 10 EMS companies globally are active in working CFX projects internally. Now these big OEMs, these big EMS they're not changing everything over, but they're certainly beginning to implement this, see how their companies can benefit from this, and then they can expand out after they have done some initial trials. I've done 6 presentations to EMS companies in Europe who've talked about how CFX, they've been asking a lot of questions as to how CFX can help them. And then there is an industry consortium in the UK who has been very helpful in CFX implementation. This is the Manufacturing Technology Center, and we're working with them to try and for older pieces of equipment that may not have the ability to update all the software, to try and build some add-on boxes. We're designing an add-on box so that rudimentary information about CFX can be pulled off of legacy equipment. So a lot of work being done by members of industry to try and help CFX be more effectively used by our members. As I mentioned, we've had a number of demonstrations over the years. This includes multiple activities in US, in Europe, at the LEAP show in China. And so to try and show what CFX can do, we've done physical manufacturing lines in US, in Europe, and in China. So it's been very exciting to be able to see CFX in action on a trade show floor. This particular slide was from the LEAP show a couple years ago. We did a demonstration, and all of these companies are supporting CFX, and certainly everybody's interested to look at how this might help and get a feel for how Factory of the Future may work. This was one manufacturing line, and the host structure as to how this was working. This was from the LEAP show. We have something very similar for Apex and SMT in Nuremberg and Prototronica, where we had a connected factory exchange. We had dozens of pieces of equipment communicating actively, and you could monitor the progress on these various pieces of equipment on the mobile phone of the participants in the show. And so we had a lot of success in the demonstrations here. So our goal is to support electronics manufacturing, to try and gather information and help the EMS companies make quicker calls, eliminate false calls, provide opportunities to add artificial intelligence to even be faster and better, and trying to help the companies support their operators with AI tools to be more efficient. So to have clean data that's well understood, that can actually then be used to create feedback loops is something that we see as the future for CFX. Thank you for the opportunity from TEMA to talk to you about CFX today, and I do hope you will take a look at this standard, determine how it may help your company in the future.